CIT 1121 presentation video, Module 1, Submodule 3, and Submodule 4, possibly even Submodule 5. I'm not sure where we're going to stop on this one. Submodule 3, Network Representations and Topologies. This is just talking about the whole idea that you can draw a picture of things, and the pictures are really, really important. And this slide shows you the default icons that you'll use for different pictures of different devices. So, for instance, a desktop computer looks like a desktop computer. That's pretty easy. And an IP phone looks like an IP phone. A router is always a circular thing. It looks a lot like a hockey puck. A switch is a small square, like a donut box. And there are some, different mutations of those, like the wireless one has an antenna and a multi-layer switch, which is essentially a switch that does routing duties, is a big cube that looks like it has a router in the middle with a bunch of arrows pointing out of it. I don't know where that one came from. Anyway, you need to memorize these types of pictures and associate them with the correct things. So when you do your network diagrams, as everyone does, you'll draw the right shape for the device. What a switch does is totally different than what a router does. And if you draw your router as a donut box, like a square, and you draw your switch as a circle, people are going to be totally confused because the standard de facto science behind this is that routers are circles and switches are squares. So just keep that in mind as you go through and you learn more and more about this. Also, this is kind of cool. Wireless technology kind of uses like a wavy line, like a radio wave. It's like a radio wave moving on. And a regular old Ethernet cable, a LAN cable, is just a straight line, just a draw a line, and that's an Ethernet cable. If it is a serial WAN connection that is not Ethernet based, you will use kind of a jagged, like Shazam-like line, and you can see that there in that WAN media there, that kind of just like a little jagged line. That's to differentiate that is not Ethernet. That is going to be some other type of solution that's being used for that particular cable communication. Each one of these cables here are plugged into some type of interface or port, and they do mention here, it says, note, these terms are often used interchangeably. That's absolutely true. So if somebody says NIC or interface or port, that's what they're talking about. Usually I try to say physical port as an actual location, and interface is what we're configuring within the equipment. So a lot to be said about just the basic nomenclature of the networking professional. These are some pretty cool pictures, networking topology diagrams that have been built. One of the most important things is this: is if you're going to build a network, you need to have a picture of it first. Having a picture of the network allows you to figure out what you're supposed to plug in where. Without a picture, you've got nothing. When I used to do consulting and we go and talk to people and they would tell us what they wanted with their networks, I would sit down and I would, sounds crazy at first, with a piece of paper and a pencil or a pen, and I would draw out what I thought that they wanted, and you would use the standard diagramming techniques as listed here: circles for routers, rectangles for switches, squares for PCs or end host devices, laptops. These are a little bit fancier than what I used to use. And whenever you get to the internet, you would just draw this cloud piece. And the cloud just meant I don't really know what's going on in there, but I know I need to connect to it. So, and that was absolutely okay. That's a totally fine thing to draw, is a cloud for the topology diagram. Okay, cool. All right, let's get into 1.4, which is different types of networks. And they're really, the two major types of networks are called LANs and WANs, right? So there's a local area network and there's a wide area network, but there's different sizes of networks that you might set up. Small home network, a small office, home office, that's called SOHO. That's a really cool way of saying small office. Worldwide web, internet, and medium to large. Hey, I have a large organization. Maybe we have multiple sites or locations where we have hundreds or thousands of computers connected. In any one of these cases, the scalability, which means the size of the system, it has to work for big and for small. And luckily for us, the addressable structure and the way that these devices communicate is called TCP/IP.
and that will work for small networks, and it also works for large networks. And more on that when we get into other slides and communications. This just shows LANs and WANs. Um, a WAN is whenever you're going to leave a site and go someplace else. So a WAN is a wide area network. When you're in a specific location, that would be a LAN or a local area network. A network is also defined by the subnet that it's a part of. So when someone says network, a lot of times they're referring to devices that communicate with each other without having to go through a router. Will be something that someone might say. You could have a LAN or multiple LANs at one physical site. Like for instance, this central site here has a couple of layer 3 switches, which are essentially routers. And then you've got a couple of devices down here, and they may not all be in the same subnet or in the same network. They might be in 2 different networks or maybe 3 different networks. It's hard to say exactly without more documentation here, but usually when you say network, you mean devices that are on the same subnet or can communicate with each other freely just through a switch, not through a router. More on the difference between switches and routers also coming up, not right now. WANs and WANs again, interconnecting devices, and just some highfalutin terms here. LANs, end device to end device through a switch. WANs, usually router to router, as you see here. So this is the difference here is this is a LAN on the left and a LAN on the right. And these are people that are actually working. That's what, I mean, that looks like a tarantula or something. But trust me, if this slide was blown up a little bit bigger, it is a dude at a desk with a purple shirt on, sitting in a chair, typing. Even though it kind of doesn't look like that as it's so small, but you get the basic idea. Let's move on to the next slide, which talks about the internet. And the internet came around. United States Department of Defense decided that they would like to have a protocol, a method to allow all of their military bases to communicate with each other and not have a hub and spoke type of situation, so that Fort Knox, I don't even know if that's a military base, but could communicate with another fort someplace else, and it didn't have to go through a communications fort to make that happen. So what they wanted was interactivity, direct wiring between all of the forts, so that if one of the forts maybe got blown up, all the other forts would still be able to talk to each other. So they have what we refer to as a full mesh topology. And if you look at what's going on here in the middle of this section with these 5 layer 3 switches, they're all talking to each other. They all have 4 connections going out to the other devices. So if we look at this one here, connecting 1, 2, 3. Oh, we're missing one. Sorry. There is one that's not connected. But what they're looking for is a full mesh style of communication where all the devices will have a direct communication with another device. That built the backbone of the internet. And what happened was after they connected these military bases together, they said, wow, hey, this is really great. We can share all kinds of information across these lines. I wonder if anybody else is interested. And then hospitals and universities started to get involved. And then here in Illinois, actually, they came up with a product called a browser, and that allowed you to look at text and pictures across the internet. And then the rest is history, right? So it's just grown and grown and grown from there, and it's now our major source of entertainment and communication and many things. So the internet has grown from there. There are some organizational standards that they mention here: the IETF, ICANN, and IAB. Just some standards. Oh, I just switched that one around. Let's go ahead and fix that back. There are some standards that are set in place so that if we want to expand the internet further, we know how it was built previously, and we'll be able to build within the confines of the existing solution that's been built for the internet. Okay, and as new best practices evolve, those new best practices can be implemented and added to the infrastructure of the internet and make it better and faster. This slide just talks about the idea that there is an internet, which is around the outside, which is the world. And then there are 2 other terms to define on this slide. the extranet, which is where organizations or people share security measures and information just to each other. And then there's something called an intranet where you share your information with just people within your organization. So the internet itself, the extranet, which is companies sharing resources, and the intranet, which is just inside of the same company, not for use by the outside world. Since we're going so well here, let's go ahead and do 1.5 here with 3 and 4. So we're going to talk a little bit about internet connections, and in the internet connections, the first thing it gets into is, hey, how do I get connected to the internet from an end device like a home or an office or something like that? And there's a whole bunch of different ways that you can get connected. And in most cases, you will use some kind of cable, whether it be fiber optic or possibly offering what they call a broadband usage, where the cable will provide you with the ability to run data across it to gain access to the internet. So that could be coaxial, it could be fiber optic, it could be twisted pair in nature. It's going to have there will be some kind of cable. A subset of that is a DSL, which is a digital subscriber line. And a DSL line is a high-speed connection that runs over the infrastructure of telephone lines. So a long time ago, Alexander Graham Bell created the telephone. And it worked out so good that everybody in the world wanted one. And he started a company called Bell Telephone. And it absolutely put out the cable and built a system so that everyone can connect to the telephone. And we went from just individual people calling an operator that would plug in to people dialing phone numbers to PBX, which were those are just systems that handle multiple phone calls, to extensions off of phone calls, to call waiting, to call forwarding, so on and so forth. You know the story. Telephones, pretty big deal for a very long time. And the infrastructure was there. So every home in America had a telephone line that was plugged into it. Oh, well, this seems like a really good solution. If we don't have to run media like twisted pair cable, and we can utilize the telephone lines that are already in place, we can put these digital subscriber lines to work. So we're going to run data across an infrastructure that was originally created for telephones. And the bandwidth required for a telephone call is not a lot. It's actually very, very slight. So the DSL lines weren't necessarily as fast as some of the newer installations of cable, but they did work. And it's something that is out there. Other types, cellular, everyone knows about 3G and 4G. And one of these days, 5G, even though it's been advertised for like a year, 5G will actually be available and you'll be able to get super fast service on your phone. Satellite providers, I think everyone's somewhat familiar with satellite. The biggest satellite provider is a company called Hughes. You could use it as a backup internet, or if you live someplace where you don't have a cable in the ground that comes to your home, like maybe you live in the middle of a cow field in Montana or something, where there is no cable and there is no wireless broadband last mile, you could use satellite. So you could push all the way up into a satellite to get your data. And then the last one, dial-up telephone. Similar to DSL, but we're actually going to utilize the telephone system, its addressing codes for telephone numbers, and dial up another from computer to computer. We'll use modems, which means modulate and demodulate a signal, make some weird sounds. Those translate into zeros and ones, and you can pass data that way at a very, very slow rate. All right, cool. So that's a pretty cool slide. More solutions as far as internet connections. This talks about business internet connections like dedicated leased lines, oftentimes referred to as T1 lines. You may have heard of those before. They send data solutions through what was originally a voice solution, but have been adapted to digital circuits and they now are primarily used for data. And a standard T1 line is 1.544 megabits per second, which in today's day and age is not super fast. So they're kind of getting phased away. In my lifetime, I remember when I first heard of T1s and thought, oh my gosh, 1.544 megabits is so unbelievably fast. I wish I had that in my house. And to now where I'm like, oh my gosh, why would I ever pay for a T1 line? So it is a traditional transitional data voice solution to get data to organizations. It's also incredibly reliable. It's built in a very reliable infrastructure and it works real good and there's very little downtime. So it is an option. Another option is something called Ethernet WAN. Ethernet is a method of passing data across a copper wire. Generally, it doesn't have to be copper, but it is a frame header solution. It is quick, it is fast, it is efficient. Ethernet really works, and it works for all of your LANs, and we're going to talk about Ethernet a lot in this class, but we can set up Ethernet for WANs as well. And one of the great advantages to an Ethernet WAN is it's going to be really fast because your LANs are going to be generally faster than your WANs. Just like your local area network at your house is probably 1,000 megabits per second, but your internet connection at your house is probably less than 1,000 megabits per second. I do notate that this is 2020, and in a few more years, that whole thing could switch the other way. DSL, I've spent too much time talking about that already, and satellite. Too much. Let's move forward. Converging networks. The idea behind the converged network is this, is once again, a long time ago, there was a system that we could use for data. There was another system that we could use for telephones. And there was a system that we could use for television. And they were all independent systems. And if your phones were down, no big deal. You could still use your computer and you could still watch TV. But what's happened in the last few years, specifically here in the United States, is these things are starting to come together. So they have telephone systems that work over data lines called voice over IP data. And then there is video over IP that you can use for television. And everyone's now seeing that, hey, why should I buy cable TV and pay $200 a month to Comcast when I could just get it for $39 a month on YouTube TV or Hulu Live or whatever? It's the exact same thing. Yeah. So what's happened is this, is we're converging these systems. So we don't have to have the infrastructure of a data system and the infrastructure of a phone system and the infrastructure of a network broadcast system. We can converge these down into just a data system, and we can run data, and we can run video, and we can run voice on the same wires. And now the amount of infrastructure that we need, the amount of cables, the amount of intermediary devices gets shrunk down. That's less stuff to buy, less expensive, and we've gone through a transition period in the last 20 something years of getting voice traffic to sound good over a system that's built for data and getting video to not buffer all the time on a system that's really built for data. It's not built for live streaming television solutions, even though we're using it for it and it's working. We're getting better at it. And the better we get, the more it's going to be a converged system. So when people talk about convergence, that's what they're talking about. They're talking about rolling in the phone and the television into your data system, which a lot of you younger people are doing already anyway. And I already talked about this slide. So that's where I'm going to cut this one off. I think this one's been long enough. And we'll get into whatever's in 1.6 in the next video.